So the question here is, consider the following grammar that admits a series of declaration followed by the expression and the associated syntax directed translations actions given as a pseudocode. So if you will see here, P derives D star E star, D is integer ID, and record that ID dot lexeme is of type integer. So basically here you can say it is the declaration part, and it is if you will see here that it is syntax directed translation SDT part is given to us for the following rules, right? For example, it is rule number 1, you can say it is rule number 2, rule number 3, rule number 4, rule number you can say it is a 5, and rule number 6. Okay, so we have a declaration, series of declarations are here, and they are associated with this respected SDTs, right? Now, with respect to above grammar, which one of the following choices is correct? Okay, so basically, if you will see here, we have a declaration, then record that id.lexeme is of type integer. Okay, so basically rule 2 and 3, we can deduct that we are entering into the symbol table, and then type checking is performing, right? We are performing type checking for syntactically correct integer variables. Why? Because if you will see at last, eid is derives and set e type equals to integer, right? So at the bottommost part, the complete derivation would be on the integer expression. So options, if you will observe, the actions can be used to type check syntactically correct integer variable declaration and integer expression. It seems to be most correct answer among all the 4 options. So C is 101% correct answer, that we are, that these actions, SDT actions, are using to type check, for type checking syntactically correct integer variables declaration and into integer expression. So option C is correct answer, guys, for this question. So here question is, consider the following context free grammar where the set of terminals is A, B, C, D and F. Okay, so if you will see here, this is the CFG which is given to us, and set of terminals are A, B, C, D and F. Okay, and the following is a partially filled LL1 parsing table which is given to us. It is partially filled LL1 parsing table, and we have the question have asked us that which one of the following choices represent the correct combination for the numbered cell in the pairing table. Blank denotes that the corresponding cell is empty. Okay, so we need to replace this 1, we need to replace this 2, we need to replace this 3, and we need to replace this 4. So if you will see here, guys, on the place of first, I will replace the production of S. For example, the first of S is D. So this production that S derives DAT, I would place in the D block of this S non-terminal, right? So it is already here. Now, if you will see here, I have non-terminal. In this case, I will find first of S again. So first of S again, I can replace this R with first of R. What is first of R? First of R is C and epsilon. So if I will replace this R with C, in that case, it would be CF. So it simply means that S derives RF, I can place in this block, that S derives RF could be here. Why? Because R can be replaced with C, and then CATR would be the corresponding production for this one. So because first of S we are getting here C as well. So on first on the place of 1, I will replace it with S derives RF. On second, if you will see here, second, if I will replace this R with epsilon, I can also replace this R with epsilon. Why? Because first of R is epsilon as well. In that case, S derives F is here. So first of S is F as well. First of S is F as well. That is why on the place of 2, I can also replace it with S derives RF. Why? Because on replacing this R with first of R, I am getting C and F at the starting position of this right hand side production. That is why on the place of 1, S should be RF, and on the place of 2, S should be RF is there. Now let's see on the place of 3. So we have replaced 1, we have replaced 2. Now on the place of 3, if you will see T on C block. So if you will see T, AS. So on A block it would be there, on B block this production would be there, and on the remaining block I need to put T d rise epsilon. So on the place of 3, T d rise epsilon would be there, and on fourth dollar. So on basically we have epsilon production here. So on remaining block T d rise epsilon would be there in each block. In each block T d rise epsilon should be there because we have epsilon. So whenever we have epsilon production, we need to put it into each block of that non-terminal. So let's match it with the options. Option A, it is eliminated. Option B, it is again eliminated. Option C, eliminated. Option D is the correct answer. S d rise RF, S d rise RF, T d rise epsilon, T d rise epsilon, right? So option D is the correct answer for this. Very easiest question. Use concept of first and follow, because LL1 grammar, guys, LL1 grammar completely based on first and follow set. So you need to know the concept of first and follow. If you have the concept of first and follow, you will easily answer this question. So what generally you need to do, you need to put the right hand side production into the first of that non-terminal, right? So for this question, option D is the correct answer, guys. Thank you. Question here is, consider the following statements. Statement 1 is, every SLR1 grammar is unambiguous, but there are certain unambiguous grammars that are not SLR1. Okay, and statement 2 is, for any context-free grammar, there is a parser that takes at most order of n cube time to parse a string of length n. Which one of the following option is correct? S1 is true and S2 is true, S1 is false and S2 is false, S1 is false and S2 is true, and S1 is true and S2 is false. Okay, let's find it. So statement 1 is S1, every SLR1 grammar is unambiguous. So if we make the Venn diagram, I can explain it to you like SLR1 grammar is here, and it is our SLR1 grammar. Basically it is a subset of unambiguous grammar, right? Unambiguous grammar is there, right? And SLR1 grammar is subset of unambiguous grammar. So every SLR1 grammar is unambiguous grammar, but vice versa is not always true, right? That is why S1 here, it is a true statement that SLR1 grammar is unambiguous, but there are certain unambiguous grammar like this one is a certain unambiguous grammar that are not SLR1. It is 200% true, right? So S1 is false, it is eliminated, it is also eliminated, right? Now we are left with only option A and D. Okay, go to statement 2. For any context-free grammar, there is a parser that takes at most order of n cube. Okay, so guys, there is an algorithm called CYK algorithm, and using this CYK algorithm, we can perform membership test. What test? We can perform membership test on CFG, right? We are finding it on CFG, and we will definitely find that yes, order of n cube time will be required to parse a string of length n. So option S2 is also true. So option A is correct answer. So here both the statements are true. That is why it's option A is correct. Hey guys, the question here is, consider the following C code segment, and C code segment is A equals to B plus C, E equals to A plus 1, D equals to B plus C, F equals to D plus 1, and G equals to E plus F, right? So in C code segment, we have 1, 2, 3, 4, and 5 lines, right? Now question here is, in a compiler, this code segment is represented internally as a directed acyclic graph, that is DAG, like that. The number of nodes in DAG is, we need to count number of nodes in this DGA, directed DAG, directed acyclic graph. Okay, so let's solve it. Suppose at first we are adding from line number 5, that is G equals to E plus F. So G is equals to E plus F. E plus F means we have added E and we have added f, and the result of E plus F would be here. Now if you will see here that F equals to D plus 1, F equals to D plus 1 and E equals to A plus 1. Just focus here. E equals to A plus 1 and F equals to D plus 1. And if we talk about A and D, A equals to B plus C and D equals to B plus C. A equals to B plus C taken from line number 1, D equals to B plus C taken from line number 3. So both are equal. So B plus C, let's do it first. B plus C, let's do it first. Suppose it is B, it is C. So here B would be there, here C would be there, and it is nothing but B plus C is A or D. So you can say that result will be stored here. Okay, result will be stored here, and it is nothing but B plus C is added. It is nothing but A or D. That both are equal. Both are equal. Now E plus F, we need to add A plus 1 to it. So we need to A plus 1 to it. So suppose 1 is here. Okay, 1 is here, and we are adding the result of this one to this one, because E is also A plus 1, F is also D plus 1. So in this sequence, if you will observe number of nodes, node 1, node 2, node 3, node 4, node 5 and node 6. So total we have 6 nodes. How many nodes? We have 6 nodes. You can take it like we have one node it like that, then we have another node here, G plus E and F are here, then we are adding it with 1, it is another node, and then we are adding it with the result of B plus C. Okay, so 1 2 3 4 5 6 nodes. 6 is the correct answer, guys, for this GATE question. I hope it is clear to you. Thank you. Hey guys, the question here is, consider the following statements. 2 statements we have given. S1, the sequence of procedure calls corresponds to a pre-order traversal of the activation tree, and the sequence of procedure returns corresponds to a post-order traversal of the activation tree. Which one of the following option is correct? Okay, so basically this question is from RTE, that is runtime environments, and to solve this question conceptually we can do one thing. We have two approach. Approach 1, I am directly solving the question. Why I am directly solving the question? Just observe the things. The sequence of procedure calls correspond to a pre-order. We can directly say that in procedure calls, parent will call its child first. It is similar to pre-order. That is why S1 is true. Now S2, the sequence of procedure returns. In procedure returns, child will return first and then parent will return. Child will return first and then parent will return. It similar to post-order traversal. That is why it is also true. So both the statements, that is S1 is true and S2 is also true. D is correct answer. But I have approach 2 as well. What is my approach 2? Approach 2 is practical approach. You can do it like this. Okay, suppose I am making an activation tree. Suppose 1, okay, 2, 3. Okay, suppose here is there one thing and here it is something. Okay, now suppose I have function A, I have function 2, I have function, okay, A, function B, I have function C, I have function D here, and suppose I have function E here. Okay, so I have 5 functions A, B, C, D, and E. Now for statement 1, that is procedure calls. That is procedure calls. For procedure calls, if you will see, A will call to B, A will call to B, B will call to C, then B will again call to its child because C doesn't have any child, so D will get called. Now B, that is the parent child of A, it is already evaluated, so B is evaluated, C is evaluated, D is evaluated. The next child of A is E, so E will be evaluated, right? So this is the procedure calls. If you will observe this procedure call, you will see it like it seems similar to pre-order traversal. Pre-order traversal, isn't it, guys? That is why it is true. That is why it is true. So statement 1, S1, it is true. Now for statement 2, that is procedure returns. That is procedure returns. Okay. For procedure returns, okay, let's change the color. For procedure returns, child will be evaluated first. Child will return first. So A, it will go to child B, B again have child C, C doesn't have any child. So it is leftmost child C, it will be returned. After that D, it will be returned. After that B, it will be returned. After that E, because it is a child of A. In return, child will be returned first, E, and then A. So in returns, the order of traversal in the activation tree would be like this. If you will observe this, this is similar to post order traversal, isn't it, guys? That is why statement 2 is also true. Now we have discussed 2 approaches, approach 1, approach 2. From both this approach, you can grasp the solution. Hence, option D is correct answer for this GATE question. I hope it is clear to you guys. Have a very nice day. Jai Hind, Jai Bharat.